I've got me a nice dick insider. Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Cheers, guys. Today I've got another kit to build here. It's another Short Circuits series. It's project number 9 from Short Circuits Volume 3, the Light Scanner Chaser. Basically, it scans up and down like you see in sci-fi movies. And similar to Kit from Knight Rider. Anyway, there's not much really to talk about this. An impressive display using 20 LEDs that chase forward and backward, just like scanners seen in space movies. Oh. Kit includes PCB, LEDs, and all electronic components. It looks like they're using 20 LEDs here. Kit requires 12 volt DC, like they all do. Use Project 28A, which is just a regulated power supply. Instructions, there's the part number for that in Jaycar. Unfortunately, Jaycar Glenorchy doesn't seem to have the printed paper anymore. They don't even have Volume 3 book for sale. They've got Volume 2. So what I'm going to do is I'm going to look up the project in the already downloaded PDF that I've got for Short Circuits 3, and we'll have a look at how this circuit works. And here is the project here. It's Project 9, page 49 of the book. Why would you buy the book when you can just download the PDF? It's free, for God's sake. Anyway, do you like to see a row of lights chase each other? This one does even more. The row of lights chases forwards and backwards. It's a new car. No, it's just like a scanner from a space movie. Okay. And here's a schematic diagram here. It's a fairly simple circuit. Now, we've got the 12 volts coming in through a wrong way protection diode, D1 here, basically a half wave rectifier, through the power switch, through an indicator LED, which is LED 21. Just to tell you that the circuit's on, we should have around about 11.4 volts here if indeed we have exactly 12 volts coming in. That is smoothed by this bulk filtering capacitor 47 microfarad, which is actually mounted close to this IC2, which is a 4017. Now, this is a decade counter, and what that is from a clock input, it'll count from 0 up to 9 on its outputs, and then when it gets to 9 and it receives another clock impulse, it resets, goes back to 0, and the cycle repeats. Now, you can provide any clock signal you want from, half a hertz up to, several megahertz if you wanted to. It doesn't really matter. But the clock signal is being generated by this 555 timer, which is configured as an stable oscillator, and it's providing around about 9 hertz or 9 cycles per second for the clock signal. So it's going to scan or display on these LEDs pretty fast. Now, how does it actually scan up one way and then make this IC scan backwards back the other way? Well, it doesn't. It's the way these LEDs are wired. Now, we'll notice each of the outputs of the 4017 has its own dedicated transistor being driven. So there's 10 of them via these 10K resistors. And each transistor here drives 2 LEDs wired in parallel. So this one drives these two. This one drives this one and this one. This one drives these two. This one drives that one and that one. This one drives these two. That one drives that one and that one. This one drives these two. That one drives that one and that one. This one drives these two. And finally, this one drives that one and that one. So what is happening is when the 4017 gets to 4, so it goes 0, 1, 2, 3, 4. So we've got the 5th transistor being turned on. When the 6th transistor turns on, when it counts to 5, then the second set of LEDs will start glowing, and as it continues to count up to 9, it'll start to appear as if the LEDs are going backwards, back down the line, back to the left. However, they're only on separate LEDs. They're not actually lighting up the original 2 LEDs that started the process up to the right-hand side. So you get two sets of LEDs going up to the edge of the board on the right, and then the second set of LEDs taking over and then going from the right down back to the left, if that makes sense. You'll see when the circuit works what I'm talking about, but that's basically how it magically makes it count up or scan up of the LED array and then back down again. It's just how these LEDs are wired. And that's it. That's all there is to this circuit. There's nothing much more to say about it. And there's a physical diagram of the board layout. That was for when they didn't have silkscreen printing on PCBs, but they do now. These LEDs are awfully close, so the actual circumference of each LED is intersecting with the one next to it, so it's going to be a very, very tight fit. That's what she said. Okay, so let's get the contents open here so we can see what it all looks like. Bag of components with a bunch of LEDs, some solder, the two ICs, but no IC sockets. So this is going to be a test in soldering to ICs. If you've got a well-earthed iron or one that doesn't produce any ESD or electrostatic discharge, you can solder to these ICs quite fine without damaging them. Just keep the dwell time on each pin down to 3 seconds maximum, and you should be good to go. I've never had any IC destroy itself from the soldering iron, even the high-speed CMOS ones or the HCs. But these are not HCs or CMOS ICs, so you're not running the risk of destroying them with static. They're preamble crap as usual, and which is pretty useless. And their circuit board, up to Jaycar's usual standards. So this is basically and practically another useless circuit from Short Circuits. So this is basically a power switch, a diode, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 transistors, and 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 LEDs. And two ICs and a couple of resistors and a link wire, which it looks like they don't provide a link wire. Of course they don't. So I'm going to build this up in time lapse just for, something to do. And when it is built, we'll come back and test it. Okay, so before I start the time lapse, I'm just going to get out all the components into the tray here. Take this bit of paper out, just so it makes it a lot easier to assemble. The first thing I will put in are these two PCB pins. That's for the power supply connections. If I can get them out of the bag, that'd be great. There goes a resistor. I never really did like this vacuum sealed bags that Jaycar use. They're a pain in the ass. Okay, so open all Z components, drop them in the tray. It just helps keep things from falling on the floor and being lost. I might leave this semiconductor bag till last, but I want the solder out of it. So I'll grab the solder, and I'll also use up the previous solder that I've got left over from another one of these kits. Alright, so let's get building. Alright, and there's the circuit built there about half an hour later. It's not hard to build, it's just awkward because of these fiddly farty things like the LEDs and the 10 transistors here. But yeah, they've really made the fitment of this really a big pain in the ass to actually get the LEDs to all go at the right height. Because the diameter of each of the LEDs that's adjacent to it or next to it is intersecting with the one on the other side of it. So you've got like an LED circumference that's intersecting with this one intersecting with that one. So it sort of like tries to push them outwards, if you can sort of understand what I'm talking about. Right, so the next thing to do is to test this thing on a 12 volt power supply and see if it works. If it does, great. If it doesn't, well, it was only 15 bucks, so let me hook up the power supply and get that all ready to go. Okay, I've got the power supply hooked up. It's at 12 volts, 12.5. I'll just turn the load on. The switch is off. And look at that, it is actually working. I can't see any dead elements. No, they all look like they're flashing. It looks like it's going like 2, 2, 2, 2, so it's skipping the one in between. So it's like in a group of 3, but it skips the one in between until it scans back the other way, which is, yeah, okay. So we can see that circuit is working. I might actually just drop the iris of the camera so you can get a better look at it like that. Isn't that neat? And I could stare at that all day and won't achieve anything. It's not very bright because of, you know, the dropper resistors for the LEDs. Well, it's 330 ohm here on this side, but yeah, it's just these are only like 20 MCD LEDs. They're not very bright. You could swap them out for high intensity ones and get a little bit more brightness out of it. In fact, I might kill the desk light. And right away, the camera will not focus. So I'll give the iris a bit more gain. There we go. Oh, that looks a little bit more scientific, or science fiction, I should say. Nice. Anyway, I'm going to end this video here, and if you enjoyed it, please remember to go down below, like, comment, and subscribe if you haven't done so already. And this is the Astro 30 saying, see ya, have a great day, I'll see ya in the next video. Do, 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 do. I have no idea what that was.